We all missed camp.
There's like 2 Hershey bars.
Ew, that's the box I had.
The plastic board has cleared everything out. Someone gave me a $20 bill and took like the whole box.
Well, that's messed up.
He's feeding the game.
He gonna resell it.
He's making sure his family eats.
I told him to sell it for profit.
That's what I was doing.
She took your only Hershey bar.
That's
Did
just
you want that?
disrespectful.
Just get the Hershey bar open. I was going to anyway.
Ah!
Sell it for $2.
Yeah, you want it for $5. Maybe. That's it going. What's in
Anybody else?
Dude, I want to know how to act.
I'm gonna have bougie stuff this week, okay?
Bye.
I'll allow it this week, Mark.
This week.
Came out like 2 weeks.
Let me have my moment.
I'll allow it this week.
Okay. Then you've got the hole in the graph, the point discontinuity. And as I approach it from the left and the right, I'm approaching this 7 over 5, which they gave us. Vertical asymptotes. As I approach from the left and the right, it's either going to be positive or negative infinity. So as I go up, I go to infinity. As I go down, here it's negative infinity. And then, of course, domain and range. Yeah. No. Okay. Domain and range is everything except for where x's for the domain give us problems, or y's for the range give us problems. Okay, so that's what we did last time we met in a nutshell.
We were in the middle of B.
Right here. Yep. Okay, so we were starting to do the same type of stuff, but with the table. And on B, it said identify the equation of any vertical asymptote of the graph of f of x. Give a reason for your answer. Well, if you look up here, vertical asymptotes occur when f of x, which is the y, approach negative infinity or infinity. So, and that's kind of what I was, well. So if we look here, this is a fairly small number, and this is a fairly big number. So on either side of this negative 0.5, which is how I got negative 1/2, you could have written negative 0.5, is going to negative infinity and positive infinity. That means it's a vertical asymptote. So because, let me write it out. Oh, can you try to look at my finger? Can't. All right. Because as x approaches negative 1/2 from the left, f of x approaches negative infinity, getting smaller and smaller and smaller. And as x approaches negative 1/2 from the right, that's that little plus sign there, it just means from the right, so I don't have to write from the right. F of x approaches infinity. So with the horizontal asymptote, which was part A, you look at the top and the bottom, and as I approach a very small number, what f of x or y approaches is my horizontal asymptote. That's what's going on here. Vertical asymptote, you look at the opposite. You look at the y, whichever one, when it gets really big and really small, whatever numbers that's around, that's our vertical asymptote. Identify the coordinates of any hole in the graph. Give a reason for your answer. So we look at the other one. It says undefined. Notice on either side of this undefined, that it's not going to negative infinity. It's not a huge number or a small number. Those two are really close to the same thing. What would you say they're really close to? 1.6. Yeah, because one is 1.604, the other one is 1.596. So they're right around 1.6. So the whole would be, and it's saying undefined because there's technically a hole there, but the whole would be 2, 1.6, because, that's a whole, there we go, because as x approaches 2 from the left, and as x approaches 2 from the right, plus sign just means from the right, f of x, or y, is approaching 1.6. No, you're fine. It's just all the beads. I love it. Okay, D, domain and range. Okay, so let's see, yeah. Up here on number 4, how do you determine the domain? It's everything, negative infinity to infinity, except for the x-coordinate of the hole and the vertical asymptote. So let's see. X-coordinate of the hole is 2, and the vertical asymptote is negative 1/2. So my domain is negative infinity to negative 1/2, negative 1/2 to 2, and 2 to infinity. So we go back up to the top, not very close to the top, number 5. The range is negative infinity to infinity, except for the horizontal asymptote and the y-coordinate of the hole. So, horizontal asymptote and the y-coordinate of the hole. Negative infinity to 1.5, 1.5 to 1.6, and 1.6 to infinity. Every time I say infinity, I think, and beyond. Okay, see what you can do. I think we can do this. Yeah. See what you can do with, on page 320, that table. It's kind of the same stuff that we have been doing. The questions are asked in a different way. At least look at the table and think of what your horizontal asymptote would be, what your vertical asymptote would be, what the hole in the graph would be. Those are the main issues. Let's see if we can figure out vertical asymptote, horizontal asymptote, hole. Don't worry about the questions. Just see if you can pick out those 3 things. Look at the other one for an example.
is the horizontal asymptote will be, will that be free?
Answer this question with a question. The horizontal asymptote, you look at. Yeah, it's where y is when x is approaching negative infinity or infinity. So, for example, you look at the very ends and you see what these two are and see what it approaches. If it's that, then yes. Can you go back to the slide? Here? I'm going to go over it again in just a second. Give Mario a second to catch up from mentioning this.